back to this channel. So in today's class, I want to derive the formula for the sum of two cubes. We usually use this sum of two cubes when you are doing roots of quadratic equation. When you say that when you are given the roots and you are asked to find the sum of roots, product of roots, so you may be asked to find alpha cubed plus beta cubed. And I see that many students have issue with this because that is what we are treating in our class. So I observe that many of my students have challenges on this. That is why I want to treat it today. So follow me. So if you have a cubed plus b cubed, we know that it's usually a plus b multiplied by a squared minus ab, then plus b squared. But for me, I don't like students to memorize formula. I usually want them to know how it was derived. So that is why I want to do that today. So if you want to derive this formula, you derive it from a plus b cubed. So by binomial expansion, or you expand it directly, you have a cubed plus 3a squared b plus 3ab squared plus b cubed. Now say a plus b cubed is equal to a cubed plus b cubed. That is, I want those cubed to come together, plus 3a squared b plus 3ab squared. So a plus b cubed is equal to a cubed plus b cubed. Then you can factorize 3ab from these two. So plus 3ab, let's factorize. So we are left with a plus b here. If you expand this expression, you are going to get this expression 3a squared b plus 3ab squared. So now we want to make a cubed plus b cubed the subject of the formula because that is what we want. So we can now say a plus b, everything cubed. Then take this expression 3ab multiplied by a plus b. Take it out. So we have minus 3ab multiplied by a plus b is equal to a cubed plus b cubed. So invariably we have a cubed plus b cubed to be equal to a plus b, everything cubed, minus 3ab multiplied by a plus b. So from this expression in the right hand side, we can factorize a plus b out since they're having it in common. So a cubed plus b cubed will now be equal to a plus b into big brackets. So this one will leave a plus b squared for me. So I have a plus b squared, then minus 3ab, then another big bracket. So from here, I can now expand this. So I have a cubed plus b cubed is equal to a plus b, then big brackets. This a plus b squared, by expanding it, or you use binomial expansion, you have a squared plus 2ab plus b squared minus 3ab. So I repeat this minus 3ab. So we have a cubed plus b cubed is equal to a plus b, close it, then 2ab minus 3ab will give me minus ab. So I have a squared minus ab plus b squared. So can you see I've derived it? So that is how to go about a sum of two cubes. So instead of you to be memorizing formula, it is best for you to know how it is formed or how it was derived, so that whenever you want to use it during the exam period, if you forget it, if you understand how it was derived, you will quickly write it at the back of your answer booklets. You can use pencil, you can use pen. Write it, derive it for yourself so that you know whether you are online or not. After doing that, just take just a cross, put it across it like this. You'll be fine. But don't write it inside the question paper. I used to tell my students that don't write anything on your question paper. You can write it at the back of your answer booklet. Then after everything, you cross it. Just a singular, you cross it. So for some of quadratic equation, you may be asked that if you have quadratic equation 2x minus, let's 2x squared minus x then minus 2 is equal to 0. Then you are given alpha and beta as your roots. They are the roots. So you may be asked to find 1 alpha cubed plus beta cubed. Then 2 alpha cubed minus beta cubed. So there's no need for you to be stressing yourself after knowing this derivation. So you just say that solution. You know that your sum of roots will be equal to what? Minus b over a. So from here, our a is equal to 2, b is equal to minus 1, and c is equal to minus 2. So sum of roots will be minus b divided by a. So this is sum of roots. Now, product of roots alpha multiplied by beta will be c divided by a. So we need all this. So alpha plus b will now be equal to, here b is minus 1. So minus 1 divided by a is 2. So alpha plus beta is equal to 1 over 2. Alpha beta product of roots will be c, that is minus 2 divided by 2, which is equal to minus 1. So you keep all this one aside. Now back to the question given to you. You were asked to find alpha cubed plus beta cubed. So that is what we have derived. So alpha cubed plus beta cubed will be sum of 2 cubes, which is equal to alpha plus beta into brackets alpha squared minus alpha beta then plus beta squared. You leave that one. Now from here, now we now say that we have alpha plus beta. We have known the value of alpha plus beta. We have known the value of alpha beta. So we want to find the value of alpha squared plus beta squared, then minus alpha beta. So this alpha squared plus beta squared can be derived from a plus alpha plus beta squared, then minus 2 alpha beta. That is, if you want to derive sum of 2 squares now, you need alpha plus beta, everything squared. If you expand it, you have alpha squared plus 2 alpha beta plus beta squared. Now from here, if you take this alpha squared plus beta squared together, then you will make them the subject of the formula. You take away this one, minus 2 alpha, and you subtract 2 alpha beta from the left hand side. So we have alpha squared plus beta squared is equal to alpha plus beta, everything squared, minus 2 alpha beta. So that is what I derive now. So after knowing this one, you now substitute it inside this expression, alpha squared plus beta squared, then you complete it with minus alpha beta. For this alpha cube, sum of 2 cubes of roots, let's call it equation 1, and call sum of 2 squares of roots, let's call it equation 2. So that means we need to substitute equation 2 into equation 1. That is, wherever we see alpha squared plus beta squared, we're going to put alpha plus beta, everything squared, minus 2 alpha beta. So we now say that alpha cubed plus beta cubed will be equal to alpha plus beta into brackets alpha plus beta squared minus 2 alpha beta. Then you complete it with what? With minus alpha beta. So minus alpha beta. Then you cover it. That is the sum of two cubes, which is equation 1, is alpha plus beta. Bracket it, then open another bracket, alpha square plus beta square. And this alpha square plus beta square is the same thing as alpha plus beta, everything squared, then minus 2 alpha beta. After substituting it here, you will have alpha square and alpha plus beta squared minus 2 alpha. Then you complete it with minus the minus alpha beta. So that is what I've written here. So you have alpha cubed plus beta cubed is equal to alpha plus beta multiplied by alpha plus beta squared, then minus 2 alpha minus alpha. We have minus 3 alpha, minus 2 alpha beta minus alpha beta gives minus 3 alpha beta. And we have known the sum of roots, which is alpha plus beta, to be equal to 1 over 2. You have known product of roots, which is alpha beta, to be equal to minus 1. So what you need now is that you should be substituting them inside this equation 3. So alpha cubed plus beta cubed will be equal to, wherever you see alpha plus beta, you put 1 over 2. 1 over 2 multiplied by 1 over 2 squared, then minus 3 multiplied by minus 1. So which is equal to 1 over 2 multiplied by 1 over 2 squared is 1 over 4. Then minus 3 multiplied by minus 1 will give me plus 3, then over 1. So which is equal to 1 over 2 into brackets. Let's find the LCM of 4 and 1 is equal to 4. So 4 in 4, 1 multiplied by 1, plus 3, 1 in 4, 4 multiplied by 3, 12. So we have 1 over 2 multiplied by 1 plus 12, 13, divided by 4. So alpha cubed plus beta cubed will be equal to 13 over 8. So that is number 1. So we have gotten that sum. So to find difference of two cubes, the formula for difference of two cubes is alpha minus beta into brackets alpha squared plus alpha beta plus beta squared. So you can do that one, but you need to find sum of a difference of two roots. So in the next class, we'll continue from there. Then I'll show you how to derive the formula for difference of two cubes and how you are going to go about difference of roots of quadratic equation. So like I say in the next class, thank you and God bless you. Don't forget to subscribe to my channel and give it a thumbs up. Bye bye.